Organisms from ballast water, combining high efficiency in all water conditions with low energy consumption. The first treatment step is pressurized filtration. The second treatment step is UV irradiation with low pressure lamps. The third and final treatment step is utilization of the ozone generated by the low pressure UV lamps in the previous step. Finally, the treated water is ready to be directed to the ballast tanks. For additional will live and grow inside the ballast tanks. Eggs may be hatched and some organisms may survive and grow during the weeks, potentially months, that pass before the ballast water is discharged. This means that the ballast water will be contaminated by these less ballast tank maintenance and higher system efficiency. The ballast water system consists of the following parts: a filter for removing particles, zooplankton and large algae, UV lamps for generating photolytic inactivating light and photochemical ozone generating light, an ozone injector system for injection of generated ozone into the ballast water flow. The first treatment step is pressurized filtration, which removes most of the organisms above 40 micron as well as the bulk of the sediment in the water. The filter for pressurized systems is available in sizes ranging from 40 cubic meters per hour to 5,400 cubic meters per hour. The filter is self-cleaning, which means that it actively cleans the water during the entire ballasting process. The second treatment step is UV irradiation with low-pressure lamps. The advantage of low-pressure UV lamps is that more than 30% of the energy to the lamps is converted into UVC, which makes the organisms non-viable. Other types of UV lamps convert typically 15 to 18% of the energy into UVC. UV units are the core component of the system. Each unit is capable of treating 100 cubic meters of ballast water per hour. Each UV reactor consists of 9 UV lamps and a housing. This allows each UV reactor to treat 100 cubic meters per hour in salt and brackish water conditions and 75 cubic meters per hour in fresh water. The DESMI Ocean Guard system monitors the salinity of the water and automatically adjusts the flow through each reactor accordingly. The final treatment is the utilization of the ozone generated by the low-pressure lamps. Ozone is a highly efficient disinfectant, and by using the UV lamps to generate it, it comes at almost no extra cost. The ozone level is too small to be a problem for ballast tank coatings, but high enough to give that extra safety, ensuring that organisms become non-viable. Let's take a look at the ozone's way through the system. Air is led to the UV lamps inside the reactors. The UV irradiation generates ozone, which is led to the ozone injector. Here, the ozone is mixed into a substream of the ballast water, which is then led back into the main ballast water line. Before the ballast water is led to the ballast tank or pumped overboard, it passes through a static mixer, which ensures complete absorption of the ozone.